Hello everyone, welcome back to my YouTube channel. I am Keerthana K.S. from Sri Venkateswara College of Engineering, Bengaluru. Currently I am studying in BE in CSE stream of first semester from the BMW section. Today I will be discussing about the subject called mathematics, particularly about the topic called inverse square matrix by Cayley-Hamilton theorem. Before going to our main topic, let us discuss about contents. Introduction. The Cayley-Hamilton theorem explains the connection between a matrix and its characteristic polynomial. It states that for any square matrix A, its polynomial P of A is 0. A is a square matrix of order n cross n with a characteristic polynomial P of x is equal to A minus x, where x is a variable and I is an identity matrix. Cayley-Hamilton theorem. Cayley-Hamilton theorem was given in year 1858 by two mathematicians, Arthur Cayley and William Rowan Hamilton. The Cayley-Hamilton theorem states that all real and complex square matrices will satisfy their own characteristic polynomial equation. This implies that when a square matrix is transformed into a polynomial, then this polynomial will be equal to 0. Cayley-Hamilton theorem is a very important result that is used in advanced linear algebra to simplify linear transformations. In this article, we'll learn more about Cayley-Hamilton theorem, its statement, proof, and associated examples. So what is Cayley-Hamilton theorem? According to the Cayley-Hamilton theorem, a square matrix will satisfy its own characteristic polynomial equation. A characteristic polynomial is associated with the determinant of a matrix and the eigenvalues of the matrix will be the roots of this polynomial. Suppose a square matrix A is given by n rows and n columns. The characteristic polynomial of this matrix is given as determinant of math processing error. Here math processing error is the identity matrix. Math processing error is a scalar quantity and signifies the determinant operation. Now we learn about what is Cayley-Hamilton theorem statement. The Cayley-Hamilton theorem states that the characteristic polynomial expression of a real or a complex square matrix will be equal to 0 matrix. The characteristic polynomial P of math processing error, which is equal to determinant of math processing error, can be decomposed as P of math processing error is equal to math processing error. This is a monoid polynomial where the leading coefficient we have P of math processing error is equal to math processing error. On replacing the math processing error with the matrix A, the polynomial can be written as follows. P of A is equal to math processing error. Now, according to the Cayley-Hamilton theorem, this polynomial will be 0. Thus, P of A is equal to math processing error is equal to 0 or P of A is equal to 0. Cayley-Hamilton theorem example. Suppose a matrix is given as A is equal to math processing error. The characteristic polynomial is math processing error. Use the matrix A in place of the variable to get P of A is equal to A2 minus 5A minus 2I, which is equal to math processing error. Now perform the required computations to get the final value as 0. Now let us move on to our next topic is Cayley-Hamilton theorem formula. The Cayley-Hamilton theorem formula is extremely used in performing complicated calculations with speed and accuracy. It also be used to determine the inverse of a matrix. The formula is given as follows. Suppose the characteristic polynomial of a n cross n square matrix A is given as P of math processing error is equal to math processing error. Then P of A is equal to math processing error which is equal to 0. Thus, P of A is equal to 0. To determine the inverse, multiply this equation with A minus 1. So, math processing error is equal to 0. Next, A minus 1 is equal to minus of math processing error. Our next topic is Cayley-Hamilton theorem proof. In pure mathematics, several methods are available that can be used to prove the Cayley-Hamilton theorem. However, the easiest method is by using substitution. Let matrix A is equal to math processing error. According to the Cayley-Hamilton theorem, P of A is equal to A2 minus A plus D into A plus AD minus BC into I is equal to 0. The proof of this theorem is given as follows. A2 is equal to math processing error. A plus D into A is equal to math processing error, which is equal to math processing error. Next, AD minus BC into I is equal to math processing error. A2 minus A plus D into A plus AD minus BC into I is equal to math processing error minus math processing error plus math processing error. A2 minus A plus D into A plus AD minus BC into I is equal to math processing error. Similarly, the Cayley-Hamilton theorem proof can be given higher or lower matrices. Now let's move on to our last topic, Cayley-Hamilton theorem applications. So we'll learn about what are the applications of Cayley-Hamilton theorem. Cayley-Hamilton theorem forms an important concept that is widely used in the proofs of many theorems in pure mathematics. Some of the important applications of this theorem are listed below. The Cayley-Hamilton theorem is used to define vital concepts in control theory, such as the controllability of linear systems. In commutative algebra, Nakayama's lemma can be proved using a generalization of the Cayley-Hamilton theorem. The theorem of Jacobson can be proved using the Cayley-Hamilton theorem. Now let us solve some problems. P of A is equal to A square minus 2A minus 3A plus 6I minus I. Now A square minus 5A plus 5I. Now we have to substitute the values and multiply by matrix multiplication. On solving this problem, we'll get the final answer is identity matrix. Now let me discuss one more problem. Given matrix 1, 2, 3, 4, let 1, 2, 3, 4 is equal to A. P of lambda is equal to determinant of lambda I2 minus A. P of lambda is equal to determinant of lambda minus I minus 2 minus 3 lambda minus 4. P of lambda is equal to lambda minus I into lambda minus 4 minus minus of minus 2 into minus 3. Now, P of lambda is equal to lambda square minus 5 lambda plus 4 minus 6. P of lambda is equal to lambda square minus 5 lambda minus 2. The Cayley-Hamilton theorem states that P of A is equal to A square minus 5A minus 2I is equal to 0. 0 is equal to A square minus 5A minus 2. Multiplying both sides by A inverse. After multiplying, we'll get this answer. A inverse is equal to minus 2, 1, 1.5 and 0.5. Thank you for watching my video. Please do like, share and subscribe.